Welcome everyone to our 5th lesson. Last week we looked into basic services. We created our first record class and our first migration class, which is a blueprint for the data we want to store in the database. Actually, I'd like to draw your attention that I made a typo, and due to that, it didn't. The name of the class didn't follow the usual conventions. But so I named the class migration, and we usually call it migrations. So there's a little bit of difference there, but yeah, you know, conventions is an important thing. So where we left off, the last lesson was the part where, due to some error, the migration didn't run and the table wasn't created in the database. Actually, I forgot about it, but it's a known issue that sometimes when you have a module enabled and then you add the migration class to it, it doesn't get processed and it doesn't run. Actually, there are some suggestions on how to make a workaround with it. One of them is creating an update method, which we didn't show last week due to the lack of time, but that would be the next part of how to handle migrations. So let's talk about the update method. So basically, we have a create method which returns a value of 1. So this is the value that will identify the version of this current migration. So the database, so Orchard will know what step was already executed. Now, every time you create a method in a migration class, you need to return some value, and that will be the version of that method or that step. And obviously, the create method returns 1 because this is the first version. Now, if you want to make changes to the scheme of the database, or actually this table or other tables, you need to use the update methods, and this follows a very simple convention. If you have a return value from the last methods of, for example, n equals 1 in this case, then you need to have a method that's name is update from n, and since the create method returns 1, we need 1 for n. So if you have, for example, 3 update methods, so you have create, update from 1, update from 2, and update from 3. Update from 3 will return a value of 4, sorry. And then if you want to make more changes, then you need to create a method that's name is update from 3, and the value will, update from 4, and then the value will be +1. So always +1 because create returns 1. So this is a very simple convention. And another important thing, it's another convention, and there are 2 separate ways to do this. So one of them is that if you make some change in an update method, you can propagate those changes into all the other methods. So if you install the module to a completely new instance, you may want to jump all the update methods and then just execute all the commands held in these update methods at once. So one of the conventions is that you write every change you made in the update methods into the create method as well. So the create method will contain every change from, for example, update from 1, update from 2, and etc. And then the create method will return a different value from 1. For example, if you have multiple update methods, you're going to return the same value as the latest update method. So if you have update from 3, which returns a value of 4, and then your create method contains all the changes from the update method, then your create method should return 4 as well. So this is the other convention is that you move every change into every update method, but that would create a mess in long term. So you won't be able to follow the changes correctly. The really good convention is that you copy paste basically. Well, it depends on the change, but you propagate every change into the create method as well, and then return the latest version's value. So that's it. In this case, if I had some other change here, in the update from one method, I would copy paste it to a create method, and then the create method should return 2 as well. So basically, that's it. Since the content of update from 1 and create is the same, they can return. They both can return 2 at the same time. But actually, this is not a real example of how to do this, because it was just a workaround to solve the problem. Because as the bug I mentioned caused the migration class not to be picked up by Orchard, and it wasn't executed. So one of the workarounds is that you write the data migration record row by hand into the database and create an update method. But actually, it didn't work this time. The solution that always works is basically tabula rasa. So we are just going to delete the database and start all over again. So I'm not going to need this method here, and create should return 1. So let's do that. And we have our instance here. So I'm just going to stop the worker process and then go to orchard.web and delete the add data folder. So we are going to start with a clean slate and just hit Ctrl F5. And as you can see, we have our admin user and password as password. Firefox remembered these credentials. And now we're talking the Orchard recipe, so we are starting this instance all over again. But of course, the changes that were made in the code base, like the overrides and things like that, are still present. It's just a database that got deleted, and the content we've created, maybe some projections and pages are obviously lost. But it's not a real problem, actually. Okay, so we have a clean installation here. I think we have our separate theme, so let's just enable it. Okay, so we are back to our nice green theme, which is a descendant of the theme machine. So the other step we need to make is to go to the modules. And since our Dojo Course demo module isn't enabled, we should do that. So just type Dojo, and if I hit enable, this time the migration will run correctly and the module is enabled now. So we have our table in the database. And now, since we have a person record and we have also a table in the database to store some data, let's create now a service class which will be related to dependency injection to make some service methods to handle some data. So the next step would be so obviously you need to keep clean your code base. So if you have, for example, service classes, it's very convenient that you create a solution folder for the service classes, which should be services. So we are just creating a new folder, and it's services. And since we are going to handle person record items, we are going to create a class, and this will be our service class called, for example, person manager. Now, if we want to use dependency injection, which was discussed on the last lesson, or maybe even the one before that, let's look into just briefly how it works. So the other buzzword that is present here is inversion of control, which is a programming method that enables you to decouple the interfaces and the implementations from each other, and the places where you use them. So in Orchard, we use the AutoFac dependency injection framework, and most of the time we use constructor injection, which means that we have some interfaces, and obviously they have some implementations too. And the way that is convenient for us is that if we want to use some services or any class which is a dependency, we don't need to know actually what is the implementation of that interface and even where it lives. We just need to have the interface. And then, since these interfaces are marked with the iDependency interface, they descend from the iDependency interface, AutoFac will pick them up and register them in its own inner workings. And now if we require some dependencies, for example, we're going to create now a service, first an interface that descends from iDependency, and then we're going to implement this interface somewhere else, for example in our controller, which will come after the service. We're going to use this interface we've declared, and we don't really need to know about what is the implementation, what is the actual implementation. We just know what kind of methods are available because we know what the interface is, and then AutoFac and Orchard will handle the rest and give us an implementation, and then we can use it to handle our data. So the next step is to create a service class, or actually first a service interface, an interface for a service class. So we have a snippet, interface, for example, iPerson_manager, and it needs to be public. So watch out for this. And now, since we want to tell AutoFac that, hey, I have an interface here, please watch out for this one because I'm going to use it later. We need to mark it as a dependency, and I can type. Okay, so it needs to, seriously, iDependency. Okay, I managed it for, I don't know, third try maybe. So this needs to be an iDependency. So let's create a few methods that we're going to need in order to make our service class do something actually useful. So first of all, let's create a method that gives you all the persons from the person table, and this should return an enumerable of person record, and this needs a using, of course, and this should be, for example, get persons. Okay, so this is our first method. We're going to implement it in a way that it returns all the person objects. The person record objects, which are, of course, the records in the table we created in the migration class. Okay, so the next one is we don't want every person from the record, but maybe we want to filter on them. So this would be another enumerable of person records with the same name, but we're going to require some parameters. And first of all, we want to filter on whether this person is a male or female, and we want to limit the number of items returned. So we have an integer and an enumerable type we've declared. And the last one is if we want to retrieve some data from the table, we obviously need a way to put some data in the table. So we are going to have another method for that, and this will be savePerson. And well, it's kind of the limit where it's convenient to have a number of parameters to a method. So we don't require now a person record object, but just make a list of the properties we have here. So we have name, we have the sex, and we have a date time for the birth date. As I really can type now. lastly, we have a biography stored for each of them. So this is our interface. Our person manager class will have to implement this one. So what we have to do here is implement the iPerson manager interface. And well, it sort of works now. If we require somewhere else our dependency, which is the iPerson manager interface, this will be picked up. We're going to receive from AutoFact this particular implementation because this is the only one yet. And obviously, if we want to use these methods, we're going to get a nasty exception, but it's going to work. So we're going to notice that AutoFact actually does its job properly, which is the normal behavior, of course. Okay, so let's go and implement these interfaces. We're going to need two dependencies for our for this service class. And the first one, we don't have the snippets here. So in Orchard Dojo, we have a page where you see a download link for some Visual Studio snippets. Basically, they contain Visual Studio snippets for this kind of private read-only fields that we use for dependencies and for whole classes, for example. Some that we haven't seen yet, like admin menu, we have content part handler snippets, so they just generate a skeleton, a code skeleton that you need to just parameterize, and it works pretty well. So check out Dojo and the Visual Studio snippets. So our first dependency that we are going to use here is a so-called repository, which basically is a very simple, I can't type, sorry, repository for handling the data that we don't store as content part and content part records, but just plain records in a table. So through iRepository, by passing it our type, what kind of type we want to handle here, we can access the actual table that stores the data for these persons. So iRepository person record, and now if I hit control dot, I'm going to use the orchard.data namespace, and this should be, as following the conventions, the name of the dependency, because it's a private field, should start with an underscore, and after that is just camel casing, so iRepository person repository. Another step here is that we have this property, but if we try to access it, it's going to be a new reference exception. So we need to tell AutoFact that please fill this field with some content, basically. And this is done in the constructor, because we are using now constructor injection here. So we're just generating a constructor for our class. And in here, we're going to make a list of the dependencies that we need to use. So this is the way how constructor injection works. So now we just have to basically copy paste this one without the underscore. And then I can just say that now when the constructor runs, AutoFact will inject the lastly registered implementation of my iPerson manager implementations. If I require an enumerable of these, then I'm going to get the list of all the implementations in the system of the iPerson manager interface. But since I'm implementing, well, this time I'm not implementing this one, but if you implement only one, if you only once implement this interface, then you obviously know that you have only one implementation, so you don't need to require a list of them, because there's only one. So now we're just going to save this reference, which is injected in the constructor. And from now on, I can use this repository. So, very simple one will be the next step, because if you look at what this person repository does, well, I don't have too much methods here to use, and they are pretty much self-explanatory. I can return how many items I have. I can create and delete ones. I can get one. I can basically make a query, and it will return the appropriate items. And if I want to return all the items that is stored in the table, I can just return the table property. So for get persons, without filtering any item, because I don't have any parameters here, I'm just going to return person repository.table, and it will return, well, it will be convenient for this return time, because I'm going to get a list of all the person record items from this table. So it's pretty easy actually. Now, the next step is that I have some filtering properties here, and this one will be very similar. So for example, I can say get persons, and I could type make a link query, but we're going to use still this table property. So if I say person repository.table, I can type some parameters. I can pass these parameters to filter the items. So I'm going to use fetch, and sorry, I'm not going to use fetch. I'm going to use where. So I need to filter these items for whether the persons are males or females, and then I'm going to limit the items returned. So the way I do this is using a lambda expression, and I'm going to check if the current record sex equals the given parameter. So I have the first filtering parameter here, and then the other method I need to use is take. So basically take accepts a numeric parameter, and it will return the first n items where n equals, for example, 5. So it will return the first 5 items from the table, and I need to just pass this max count parameter here. Okay. So now we have actually two ways to retrieve data from our table. One of them is get all of the data, the other one is contain some filtering. The next step is to be able to save some actual data into the table, so we have something to retrieve. And the next step is going to be that. So first of all, we accept 4 parameters. Some of them are pretty vital, for example, the name. So if we're going to check if there's a name passed to the method. So if we don't have a name, we don't really have to save it, because you don't really have a person without a name, unless it's John Doe or something like that. So we'll check if the given parameter name is null or empty. But it's pretty self-explanatory too. And if it happens that the user who calls this method without actually passing it a name, we're going to throw an exception. And typing is still a problem for me now, as it seems. And we're going to throw an argument null exception, because you shouldn't want to create a person without a name. So it's pretty easy. Now, let's say that we already have the data that is being provided to the method in the database. What should we do? We should need to check if the person already exists in the table. So what we're going to do is check if the name already exists among the records in the database. And the way to do this is, of course, call the repository, and we're going to use the fetch method here. So we're going to check if a person in the database exists with this given name. Now, this is important because we don't want to save we wouldn't be able to save a person with the same name again. Well, this is the fault of our implementation, but this is just an example, so it's okay. Now, if we have this person in the database already, then we just need to update its properties and then write it back to the database. If it doesn't exist in the database, we're just going to create a record and then update its properties. So the way to do this is to check if the person is null, because as you can see, this row finishes with first or default. So for a composite object, the default means that if it doesn't exist, it's going to be a null. If it exists, it's going to give back the first item that matches this lambda expression here. And let's say that it doesn't exist first, so we're just going to create a new person record object and save it to the database. And the way to do this is that you create a new person record object and call the create method and pass this new object to it. So this way we handled if it doesn't exist yet. So we don't let this one remain a null reference. We're going to create a new one if it's a null reference. And now we're just going to have to update these properties. So person.name equals name, and we're going to update all of the properties one by one. Sorry. Okay. And the third one is person.birthdate, and the last one is person.biography equals biography. Okay, so we have our person record object only in the memory yet. We have the properties, well, they already have a value, updated or new values. Now we need to put it back to the database, and all we have to do is save it, because it's going to be immediately persisted as this method finishes running. So that's it for saving records in the database.
We have seen our very basic service now, and as you have seen, this is a dependency. So we have written our first own dependency because it derives from iDependency. So we will be able to use person manager, inject it into some other type. Now we will take things a bit further. We will do a step further, and we will write another dependency, but with a little twist. And our other dependency will be person filter. We will add it to services as well. We could add it to the same file, but let's keep it clean, and let's add a new type to services. So it will be person filter. Why are we writing this person filter? We have written so this is just a new class. We have written our person manager, and this is an iDependency. So if you want to use that person manager, we will inject an iPerson manager in the constructor, and it's done. But what if we would like to have a bit different kind of dependency? Namely, here we only have one implementation for our iPerson manager, and if we would have multiple implementations, one of them would somehow win. It depends on which features are enabled and how the features are registered. Anyway, but in the end, one implementation would win. However, what if we would like to have multiple implementations for the same interface? This is commonly a case if we want to have the so-called filters. So we want to run logic, we want to run a pipeline of logic on our data for some reason. So this is actually pretty similar how image filters, for example, work. because you can use multiple image filters on an image, but the first filter gets the original image, and the second filter gets the output of the first filter, and so on. So we will write kind of a filter now. It will be quite simple again, but it's a good demonstration, I think. So it's our person filter. I've said we will have multiple implementations. So actually, this class here is, well, we will get to use it later. But first, write our interface, and our interface will be very simple. Oops. It should be public, and it will be an iPerson filter, and that iPerson filter is an iDependency. Dependency again. Make sure that your dependencies always have a public interface, and the implementations, so here person manager, we have the implementation, the type is public as well. So our dependency injection framework is in the outside. It needs to access our types. So if we don't make our interface and our implementation public, it won't be able to access it. But it could access it with some magic, but normally this is how you do it. So our iPerson filter should be public, of course. Let's write some method. This method will be very simple. It will just filter the biography. So let's call it filter biography. And it extracts the biography again. So we have our save person method here. We will use this person filter to run some logic on our biography before it is saved. Okay, so we have a method, and let's write now implementations, but two of them. The first implementation will be a filter for making bad words harmless. Very useful, of course. So let's call it bad word person filter. This class here. Well, we could actually call this file person filters. It's probably more descriptive. Of course, now we have written these person filters in the same file. We also have the person manager interface and the implementation in the same file. If you have more than just trivial things, always separate them into separate files, but for the sake of simplicity, it is not needed here. Okay, so our bad word person filter is, of course, an iPerson filter. Let's implement that again, that too. And what this will do, it will just replace some words that we find bad. So let's replace, for example, damn. The word damn. That's so bad language that I don't really dare to pronounce it again a second time. Damn. I just did it. And let's replace it with cute. Quite simple. Really nothing really special. And this time we also write another implementation. So that will be another filter, and let's call that filter short biography filter. And that's an iPerson filter as well. Let's implement the interface again. And now this will be again quite simple. It will just do the following. If the biography is less than 10 characters long, it will replace it with some other text. So if the biography is too short, so yeah, there's a length is less than 10 characters, then let's return this person has a short biography. And that's it. If the biography is if the biography is alright, then we will just return the original biography. So that's it. We have two implementations, and because this is filter kind of functionality, we want to run all of the filters through our data. So what we'll do, we will inject an iPerson filter into our person manager. But if I would just write iPerson filter here, like this, this would mean that we inject a single implementation. So we will get one object, and the object will be the implementation that has just one. And most possibly that would be the last one. The last one that autofuck registers. So I'm not sure how this works, but probably it would be the one with the name that comes later in the alphabet. So that wouldn't work, but there's a trick we can do, and that's to inject an I-enumerable of this type. Oops. So like this. And now this is not a person filter, but person filters. And I'm formatting this a bit. So this will inject all the implementations of this dependency. Very useful. So let's also save it to a field, to an I-enumerable of iPerson filter. And here too. Okay. So it's important to know here what all this dependency injection game enables you, and this is basically to make your code extensible and flexible. So when you write an Orchard module and you happen to open source it or publish it in some other way, you always have to think about it in a way that other people will use your module, other people will use your code in ways that you can't really imagine. And they may want to modify its behavior, probably slightly, probably in a bigger, having a bigger effect, but people will want to have your code as flexible as possible. Now, dependency injection enables these other people to swap some implementations out. So we have written our person manager here, but if somebody is using our Dojo Course module and they want another implementation for the person manager, like that, I don't know, saves persons in a different way, saves people in a different way, then they can write an implementation, implement iPerson manager, and the implementation would win over this implementation. So they just swapped out some functionality in our module without modifying our module. This is very important, that in Orchard we try never to modify any other code that's not our own. We don't mod anything. We just extend everything and we plug into other functionality. Also, this person filter is basically a plugin. So what we enabled in a very simple and straightforward way is how to write plugins for our modules. Our person manager now exposes a plugin functionality. So if you write an iPerson filter, you just plug some functionality into person manager. Very simple, and everybody understands it who can code Orchard, so you can make your code flexible and extensible. But after that overview, let's use our person filters after we have written them, and use it in a way. We have filters, so we want to run all of them. So let's reuse a for each, and let's iterate over all the person filters. Now person filters, the person filters biography filter method expects a string and returns a string. So we could do it like the following: the biography can be overwritten from the value returned by the filter, and the same biography is fed to the filter. So this will mean that the second filter gets the output of the first filter, and the first filter is the one that gets the original biography. And in the end, we again save our biography. So far so good. But we haven't used our person manager yet. So much coding without any demonstration. So let's write a quick controller, a small simple controller to try all this. And let's call it, for example, person controller. Oops. And I'm just cheating from the cheat sheet, so I don't leave anything out. By the way, we have mentioned this, but it's probably worth repeating it. Everything what we develop here is also available in the training demo module. So if you haven't understood something here, if you are looking for more examples, take a look at the training demo module. It's a thoroughly commented module solely for the purpose of teaching you how to develop Orchard. Okay, so let's write our person controller, and in our person controller we will use our person manager. So again, constructor injection, but let's write our person manager field first. Person manager, sorry. And then the constructor that injects the person manager. We also store it, so just the usual stuff. And now let's write a method that just saves some persons. Let's try whether person saving works. So let's call it I don't know, save persons. Again, this is an action, but it just returns a string. We don't care about views now, about theming. We just want a message that, okay, this has run properly. Save persons. If we are done, just return an OK. And before that, let's create some persons. So in our person manager, we have our save person method. Let's try some names like Jacob Gibbs. It's a male. Well, birth date, whatever. And biography is I live an ascetic life. I'm not sure whether I've written this properly. And that looks more than 10 characters, so this will be alright. Let's create another person, and let's call that Naomi Concrete to only use last names that are related to buildings. That's a she, so a female. Again, we have some birth date. Yeah, actually it's called birth date UTC, so that's a good API what we have here, because the argument names are descriptive. It wants to have UTC time, so actually I could write UTC now just to play like the rules give us. And let's write a short biography. So we want our filter to change the biography here. And let's have another person. Let's call it James Eaton. That's a male. Again, we have some birthday, and the biography would be this is a damn biography. That's it. So let's build the project first, so we can see everything is okay. Everything should be okay, but yeah, who knows? There are some errors that won't come up just in the IDE. So when writing the code, they just turn out when compiling. By the way, if you have a compilation error in your Ocean module and you don't notice it because you don't compile by hand, you just use dynamic compilation of Orchard and you just reload the page after making some change. Now if you have a compilation error, it will result in your module just not running. So Orchard will still run, everything else will be functional, but nothing will be shown from your module. So if you open up a route where there should be an action on the end, and that worked before, if you get a 404, that probably means an error 404 when trying to open up that page. That probably means that your module has some compilation errors. Okay, so let's call up this action and let's see what happens in the database. So okay, we are here. That's Dojo Course.module and it's called person controller, right? Yeah, and save persons is the action. Person, save persons. So let's see what happens. There is some bootstrapping, some startup taking some time, of course. We have written C#, so we need to wait for something, and there is some error. So let's check what the problem is. Let's attach the debugger, attach to process, and here is our IS Express. Let's attach to that. And as probably we have mentioned earlier, when debugging Orchard, it's generally good practice to enable that the CLR exceptions are shown. So how I got this menu is the following. Under debug there is exceptions, or the shortcut is Ctrl-D plus Ctrl-D and Ctrl-E. So this is the exception menu. If you are debugging something, check this checkbox at CLR exceptions. This will show you every exception that is thrown, even if Orchard somehow swallows it. So let's see what the issue is. I should have messed up something trivial or not. Okay, there is some target invocation exception. Okay, so most possibly there is some issue with our record. Or not. Yeah, by the way, we have a constraint here. So this this name column should be 100 characters long at most. So we have to do something about it to make some validation before we go further into the debugging. If we have a name that's longer than 100 characters, let's throw just an exception. So we can't attempt to save a name that is too long. So if the length of the name is bigger than 100, then let's throw argument exception. And the name should be less than 100 characters. Oops. Okay, and we need some argument. Oops. Throw new argument exception. So now comes the most fun thing, and that's called debugging and troubleshooting and bug fixing. Whatever the issue is, our migration seems alright. It has also run because Benedek has cleaned up the database. It has the proper type, it has the proper name. Our record has everything properly set up. Yeah, by the way, this virtual, this is very much needed. I can't remember whether we have covered this, but this record, so when in the person manager we access this record, in reality we are not directly interacting with this person record object. In reality, well, if I would write something here, then that would directly interact with this new person record. But after the object relational mapping layer is involved, like with this create, then a so-called dynamic proxy will be created. So basically there will be another type that will have the same properties than our person record. There will be basically a new class generated that derives from person record. It will override every property we have here. That's why these should be virtual. And by overriding it, it will capture every set or get call. Now this is needed because the underlying ORM layer and Hibernate will only know whether an object is changed or not by intercepting these calls. So if I set name on a person record, in reality I'm setting the name property on the dynamic proxy, not on the person record object directly. So this is something interesting. What you have to keep in mind all from that is that all the properties in your record should be virtual, because this is how the dynamic proxies can possibly work. So let's take a look again at the exception, because I still can't see any issues that I thought about after seeing the exception. Oops, not that. So let's attach the debugger again. Okay. What's the exception now? Fetch request must be a simple member access expression. Record name is a massive binary exception. Okay, so what is this fetch, by the way? Okay, some fun facts. We have this person record repository here. This is an iRepository. So we have a generic iRepository interface. This is a generic service that is used in order to simply access the ORM layer, simply access the database through the ORM layer. So we are just dealing with objects. Now this iRepository has some quite straightforward methods, although it would, in my opinion, need some cleanup. So basically what we use every time is create. Well, when creating a new record, of course, delete. When deleting, update is, I don't think it's needed anytime because of the mentioned dynamic proxy phenomena. You don't have to explicitly update anything. Flush is, again, I don't think it's needed. Flush would be needed if you want to flush all the changes that were made to the database objects to the database. Because of that layer between your objects and the database, if you make a change to an object, it's not necessarily sent to the database immediately. We have a get. Now this get is just getting an object by the primary key. And yeah, there's also an expression-based get. What's very important is the table, and we will get back to that in our person manager. And what's less important is everything else. So basically, count is just a shortcut for table.count. So you could write, we are back to our person manager, table.count. And that's basically the same. Because you see, our table is not an I-enumerable, it's not just a collection, but it's an I queryable. So if you write a LINQ query through this table object, through this object contained in this table property, you are really writing a query that then later translates to a database query, to an SQL query. You are not querying in-memory objects, you are querying the database. Now, these four other methods are shortcuts. So fetch is just fetching all the objects through a predicate, and then the two other overloads do the same with various other arguments. So basically, that's up to the personal preference, of course, but I prefer not to use these, but use table directly every time, because it's the same. Now, there's apparently, I haven't even seen that before, there's apparently a fetch method on iQueryable, and actually that's an extension from the Orchard framework. I don't know what it should be used for. But anyway, we don't need this. What we need is a where clause. Because what are we doing here? We are taking the whole table and we are filtering. So we need to do a where. Apparently this fetch method also accepts a predicate, but apparently it's also not working in the same way. So we need a where. This also returns an iQueryable, as we can see. So we could change other language integrated query arguments onto that. So to do the same what we have in our fetch predicate. So if we would like to page the result set in the same way as this fetch method does, so we skip and count, we could do the same through LINQ, because there is also there is also skip, the skip method, and there is also not count but take. So that's paging implemented. What we do here is we just fetch the first record. Now, by the way, another note, and this is again LINQ, not just Orchard related. Since this is an iQueryable, when we chain methods on this iQueryable object, the query won't be executed until it is needed to be executed. So we can chain further methods, we can chain a take method, whatever, as I've shown, but only the full query will be executed in the end. And when is the query executed? The query is executed when you request its result. What we do here with this first or default is we request its result, because we request the first record. So actually, with this method call, will the query be run. if you would have a count here instead of first of default, this would also execute the query because it returns an integer. So we need to run the query to compute that integer. Why I've told you this is because this is important to write efficient queries. Language integrated queries are very convenient. We love them. But we don't want to make huge queries in memory. If I would do this, like toList, toList, and then first or default, what's the difference? There's no error, we get the same first record here. Now the difference is that toList returns a list, of course. Now a list is an object that contains all the records that the previous expression filtered out, or that the previous expression returns. So this method call would execute the query and fetch all the records, and then this method call would operate on that in-memory list. Now in this particular case there is not much difference because we only deal with one record already, but if I would do this toList method would fetch the whole table, all the millions of records potentially, parse it into memory, and then this first or default method call would run on that in-memory object. So if you are dealing with iQueryables, always use this so-called deferred execution functionality of Lombiq, and always write your query against iQueryable and always execute the query as late as possible. Okay, so much talking about a single line of code. So let's reload it and see what happens. And not very surprisingly, now it's okay. Alright, let's take a look at the database. We have a toolbox here, but it's not needed. Let's open up the Server Explorer and let's connect to our database. So we have already mentioned that, but here's our solution folder, and inside that is the app data, and inside that is our sites folder, and inside that are folders for every tenant. If we have multi-tenancy, we have mentioned multi-tenancy before, but it's not important now. So here we have our default folder, and inside that we have orchard.sdf. Now this is our database. This is our database file. Every data that we have saved is inside there. So we don't use the full-blown SQL Server, just this SQL Server compact database. We will now connect to that from Server Manager. I think it's under, yeah, it's under View. Oops, it's under View. Under View we have Server Explorer, as Benedek has shown us 20 minutes ago, but the connection is broken. Okay, let's try to refresh it. Let's list the tables again, and let's call up our person record table, and it's and it's not here. Why is it not here? Probably we are looking at the wrong database. Oh, that actually looks alright. Where are we? Orchard. No, that's the desktop. That looks alright. And we have even saved everything. Dojo Course. We just tripped. Okay, we have two instances here. So That's a connection to the wrong solution. Let's add another connection then. Now to our actual workspace. And it's not bad to practice that as well. So under data connections, just click Add Connection. Microsoft SQL Server Compact is what is needed. It's on my computer. Let's browse to the database, and that is under. This is under our desktop. Yeah, we have seen where our database is. So watcha.web, app data, sites, default, orchard. We don't have any password, so okay. And now here we have our table. So right click on the table and show table data. And here we have our 3 records. This is magnificent. What we can also see that the biography from Naomi Concrete is, as expected, changed because she had a short biography. This was below 10 characters. The biography of James Itong was also altered, so he now has a cute biography instead of a damn biography. So that works as expected. Let's get back to our code and let's try to use our other method on our person manager. So we have our get persons here and the other get persons. So we have I've talked a lot about iQueryable and how to write efficient queries. Now probably you want to shout that how is this here efficient? It isn't. This is just a demonstration. Normally we don't write such record fetches. It's only useful, of course, for just very small tables, what we have here. So for now, let's write another action just so we can try out our iPerson manager. Let it be list persons, and it will just return a string of all the names. So return its person manager, get persons. Let's return all the persons now. Yeah, and let's join it with commas. So let's write a string join just with commas, so we have a nice comma separated list of names. That's it. It just outputs the list of persons. So let's try to open it up. It's the list persons action. Dynamic compilation is running. And I don't even know why you haven't shouted that I'm making a dumb mistake. Of course, we wanted to output the records themselves that won't work because we don't have a toString method defined to output the names. So we have to first select the names. Person.name. Yeah. So now we will have a concatenated list of names. And in the meanwhile, I'm showing the code so you can catch up if you are late with it. So nothing really special. And here's our name list. Wow. Everything works as expected. And believe me, this one here would also work, but let's not take time with that. Until now, we have talked about, or what we have seen, a low-level data access. So records are really the basic building blocks of OCHA's data. We have an SQL database, there are tables, in these tables are rows, and we make objects from these rows. These are called records. And vice versa, we save objects as database table rows into our database. Now that's simple and everything, but this is not what OCHA is about. But this is the very basic. So we wanted to show you how to deal with records, because sometimes this is also useful, because you don't want to store anything fancy, you just want to have your records, then do it with records. But what Orchard is about, of course, is content. More specifically, content items, content types, and their building blocks, content parts. So what we'll do next is we will start writing a content part. But content parts are very much related to records. So what we have seen here will be useful for writing our content part. Now, before we go on with actually starting to write our content part, let's take another look at the database. So this is pretty much a vanilla Orchard database. We don't have any third-party modules installed. We don't even have every built-in module enabled and installed. So we don't have that many tables, although we have a buttload of tables here. But there is some pattern you could notice here. First of all, every table is prefixed with the name of the module. So our table here is prefixed with Dojo Course module, Dojo Course _ module. So the module name is processed into a prefix for the tables, and the table, of course, has the name after this prefix as the record object, as the record class, and as we have set it up inside our migration. Now we have some other records here, and even the first one is quite notable. Well, it begins with common because it's from the common module, and it's body part record. What's in that? Actually, let's take a look. There's some lorem ipsum, and you have successfully set up your Orchard site, blah, blah, blah. Now, this text here, you have successfully set up your Orchard site, is familiar because, of course, we have seen that on the home page. This is that text. And the lorem ipsums are from our 3 default widgets. Because, as we have seen on the first lesson, or probably the second lesson, these texts come from body part. And here in our database, we have a body part record. What does this mean? This means that the body part in the background stores its data in a record. That's called the body part record. So we have our part, and there's a record. These two are somehow bundled with each other, and everything that we store in the part, in the end, is stored in the database. Now we will do exactly that. We will write a part that, among others, stores something in the database. So let's do that. I will quit everything from the database, and let's write our first part. We have done nice with this person record. What we'll do now, we will write a part that will somehow use what we have done until now. So let's write a part that uses our person manager. Let's call it person list part. This will be a very creative name, because what we use this part for is to list persons or other people. So let's add a new class to our models, models namespace, and let it be called person list part. So just as we add every record to the models namespace, it is also conventional to add every part and every part record to the models namespace as well. Actually, with records, it's also mandatory. Records will only work. They will only work if they are inside the models namespace. You can't just place them anywhere else. This may change in the future, but for now, this is a limitation. And this person list part will be a content part. Now, for it to be a content part, it will need to it will need to derive from content part. That's it. Yeah, you just have to keep that in mind. If we hit F12 and go to the definition of content part, we see it's nice and long, but in the same file we have another content part class, but it's a generic, and it also accepts a t-record type parameter. Now, actually, this is what we did that we will use, because this person list part here, just as it is now, would work. We would have, well, we would need some other plumbing to do, but generally, generally you can have content parts like that. If your part isn't storing anything in the database, you don't have to define records. So if you, for example, if your content part is displaying data from an external source like a web service, and you don't want to store anything locally in the database, you will just derive it from content part. What we need now, however, on the contrary, is we want to store something in the database together with the part. That's why we will use the generic version of content part, so that one with the t-record. But to use that, we need a record. So let's try that first. It will be a content part record. That's another class. These classes should be public as well. And let's call it person list part record. This should also derive from something. And the something is content part record. You may notice a pattern here. So parts are always named something part. Their corresponding records are always named part name record, and they derive from the respective other types. So now our person list part could derive from the generic content part and use person list record as the type parameter. Now, why is this interesting? This inheritance, because now if we want to access something from the record, we could do it from the part. We will use this part to display person objects. So what we will store among the part is some data used for querying. Notably, in our person manager service, we have this method. So let's store these two parameters so we can configure from the user interface which person objects to display. So let's store these two. Actually, for the sake of simplicity, let's store just a max count or a count. And let's start with our record. Here it's our int count. No, call it max count because that's more descriptive. Again, since it's a record, we will need it to be virtual. And what's interesting now, that now from our part, we can access this property through a record property that comes from the content part class. So what we commonly do inside in Orchard and conventionally do is we proxy calls from the part to the record, like the following. We write now a property for this max count that will just do some proxying. So that will be the same. Its getter returns the records property. And what's the issue here? Oops. I don't get it. Okay, so this should work probably. Okay. Yeah, it will just return the max count property. We have an ipsos equal setter that sets the max count to the value. Yeah. This is just some proxying. Why we do that, why we write this code that seems like some boilerplate, is that the code then later using that part won't be coupled to the record directly, but just to the part. So this is a layer of abstraction. This is not needed every time. Here in this case it looks doesn't look really necessary, but if we want to add some logic, for example, into how max count is saved, we will need that. We will need this additional layer of abstraction. Actually, spoiler alert, next time we will add some logic into this getter and into this setter. It will be awesome and your mind will be blown. So see you next time. No, and one final note here, before we finish up this tutorial. Now what we have started to write is something quite new. So probably we don't want to have this functionality, this content part, together with every other code we have written until now. What do we do now? We could write a new feature, because in our module.txt, here we have our features. It is even called features. In a module, there can be multiple features, and these multiple features can be switched on and off independently. So we could add a new feature that contains just our content part. So we don't have to switch it on all the time, but we can switch it on. And we can switch it off separately from the main code base that we have here. So as the last thing to learn today, we will create a new feature. So let's just copy paste this here. Let's call it Dojo Course.module.contents. Let's call it Dojo Course module-contents. We don't care about the description. The category is the same, and important thing, features can depend on each other. So we can write dependencies here and give Dojo Course.module here. Now this means that if we enable the contents feature, it will also automatically enable the base feature, the Dojo Course.module. If the Dojo Course.module feature is for some reason not available, you can't enable it. Also cross-module dependencies work. So this dependency is for a feature in the same module. But we could write something like orchard.widgets here. Actually, let's write it because we will need that later. This means that our feature, the content feature, depends on orchard.widgets. Orchard.widgets is an orchard module, it's built in, it's here. And this also means that if orchard.widgets is missing from this solution for some reason, we won't be able to enable our module because there's a dependency missing. And one final note, how can we tell Orchard that some code is included in a feature? So we should tell Orchard somehow that this person list part is part of this feature. It's very easy. Let's copy paste the ID of the feature, the full ID, and we will add an attribute to this type. It's called Orchard feature. We also need a namespace, and we just feed the feature ID to this Orchard feature attribute. We also place that attribute onto our report. So this means that unless our contents feature is enabled, Orchard simply won't care about these two classes. So that's for now. Thank you for your attention. We will follow up from here next time, and your mind will be blown with our what we do with our max count property. So, bye everyone.